All right, we're standing between you and happy hour, so this is going to be a bit of a challenge. Thank you for choosing to be with us. We're going to be closing today's events with an exciting talk on OCP diagnostics. So I'm Vincent Matossian, and while Arun is pulling up the slides, I'll get started. I work on infrastructure software systems at Meta, and today I'll be co-presenting with Rahul Shah from Microsoft and Arun Koshy from HPE. And we're presenting on behalf of many others who work on this initiative called OCP Test and Validation, diagnostics, many of whom couldn't be here today. And I want to give a special shout out to Adrian Inaki from Meta, who's been driving a lot of the open source GitHub diagnostics that we'll be talking about today. I'll just give Arun a minute. He's furiously programming the demo here that he's going to present to you in a few minutes. Today's topic is on the adoption of the OCP Test and Validation diagnostics. This is an initiative, a strategic initiative, part of the OCP workstream that started a few years ago. And before we get into sort of the update that we want to give you, we figured we would start by resetting what problem we were set out to solve. So as many of you know, are intimately aware with, there is a sort of need to speed up the delivery of hardware products into production. This has become a kind of new reality. This raises a number of problems that we've set out to address. Number one is, how do we accelerate the development of diagnostics throughout the entire product lifecycle, touching from NPI to sustaining and to decom? The second problem we set out to solve is, how do we build diagnostics that are portable across all the environments and use cases, so that a test that is developed, say, in the lab doesn't have to be entirely thrown away or re-implemented when it has to transition over to, say, a manufacturing environment, and similarly not thrown away or re-implemented when it goes to the data center. The third problem we set out to address is, how do we, and it came up earlier, the reproducibility of issues is a huge pain point that delays the hardware delivery to production. We need to be able to reproduce issues in order to fix them, and that applies from the hardware and software ecosystem and the entire stack. And all this plays into, how do we make it easier to share the results of the diagnostics and tests, so that we can collaborate more efficiently to accelerate root cause analysis and RMA. So really the theme is, how do we develop diagnostics faster, and how do we collaborate more efficiently? So on to the next one. One call out we want to make is a question that comes up often from people joining this work stream is, what exactly is a diagnostic? What do you mean? Is it a framework? Is it an appliance? Is it a container? So to demystify it a little bit, a diagnostic is an open source sort of standalone package or unit of execution that gives you a signal on the quality of a device or some component. We distinguish it from the test executive, that is sort of the test framework or test orchestrator that is actually typically has tight bindings into the companies, say for tight integrations to their asset management system, their PLM system for product lifecycle management, shop floor systems, or hardware health, failure detection systems, etc., making it difficult to open source the test executive themselves. So just like in Python, the tagline is, comes with batteries included. Diagnostics are also with batteries included, but they still need an operating system and a test orchestrator to be launched and sequenced. So hopefully that helped demystify a little bit what is a diagnostic. Yeah. So I can't emphasize enough the importance of collaboration efficiency. And to this point, I'll illustrate with an example. Most times for hardware vendors, for many of you in this room, you don't have access to a very large-scale test bed when you develop a product. And so when these products end up in a data center of large scale, and not to say hyperscale, we encounter all kinds of esoteric issues. They're very rare, very difficult to troubleshoot. And many times you need to set up entire IT projects just to get through figuring out what is going on. And these can be really lengthy. So you need to set up a team, sometimes fly them out to a data center. You need to design an experiment. You need to run it, to collect the data, to analyze the data, et cetera. And then you tear it all down, only to start over at the next, hopefully very rare occurrence of an event. The intent that we have, one of the objectives with OCP Diagnostic, is streamline this by making the results portable, making it easier to share results and reproduce them across those environments. So that's really the philosophy underlying the vision of this project. Where we are today, after having started this project, this initiative a few years ago, is the vision is to have sort of a meta repository of diagnostics that are available in the open source, to have sort of your compute, storage, accelerator, interconnect, and network diags, part of a test suite that would give you a signal on sort of the quality of your product, right? And to this end, we're very happy to share that we're making very good progress, but are inviting and welcoming a lot of contributions from the community. We have, on the compute side, the OCP Diag SAT, which builds on the popular stress app test that Google contributed in the open source a number of years ago. We also more recently put together the memtester, OCP Diag memtester, that is also built on the popular memtester tool. On the storage side, for those of you who heard some of the earlier talks, we have unified the storage SSD diagnostics in the OCP Diag AutoVal SSD. And on the GPU compliance checks, we have the compliance tool for accelerator management that some of you may have heard about earlier in a talk. On the interconnects, we have the PCI crawler for PCI analysis, and more recently, the lane margining tool. One other diag that we're excited to share today and making available to the community, actually you can move on to the next one, thank you, is also based on community feedback, is how do I get started developing in this format? What does it really mean? And so we've made available sort of the equivalent of a hello world of how do you write a diagnostic that uses the libraries available for being compliant with the OCP spec. And so this is now available in the OCP Diag Quick Start GitHub repo. And we're excited to share that it is available in both Python and Rust bindings. Another exciting contribution we have is backing the C++ and Python native libraries that were emit OCP compliant code. We now also have Rust native binding. So onto this, I'm going to pass it on to Arun, who'll tell you more about the community lab that we're using to collaborate and use to develop OCP Diag.
Hi. So the tests that Vincent just mentioned, we have 2 of them already deployed on a lab instance at our data center in San Jose. And I wanted to be brave today and show a live demo. So I'm going to kick that off. So this is the Diag SAT running on the node. I'm going to kick that off. And as you can see, it is producing it as per the OCP Diag specification. And we want to be extra brave. We're going to kick off memtester as well at the same time. Hopefully the network holds. So as you can see, we've got a completed diag. 2 diags done. And so this is initial proof of concept of how eventually this will be deployed across the industry. We hope to have general availability on the OSFCI tool that was released in the prior few years. So this should be connected, and all of these tests will start to get available on the CI that's publicly available. The architecture is, of course, well known from prior talks. And we would like to have help with contributions from the community as well as deployments. And as part of further innovation, we have a tie-up that's coming up, which is very exciting, which is that we also will be supporting the open source virtual client from Microsoft. And here to talk about that is Rahul.
Thank you. Thank you, Arun. So last year, around the same time, we had an exec talk on virtual client. This is the open source platform from Microsoft. And internally, it's a standardized platform that can abstract the workload, the benchmark that you use during the various phases of NPI projects. I'm happy to announce that for last 1.5 years, we have been partnering with the OCP Test and Validation team. And as a part of that, and you can see the QR code on the top left, and you can access more detail. The virtual client has a concept of profile. Now, using profile, you can abstract the execution runtime for the various capability. And in this case, the capabilities are the benchmarks, the workload that we use. And we have extended this feature, this profile feature, to support the OCP diagnostic schema. So it means that some of the capability of the virtual client as a first proof of concept has already been supported through the OCP test and validation diagnostic schema. And one call to the action, as you can sense that there are 40 plus various capabilities that we have, our ask to all of you is help join this open source initiative, virtual client, OCP test and validation initiative, either one of them, to extend this capability and make use of it across the board so that we can reconcile the diagnostics as the NPI system moves from EVT, DVT to scale testing all the way up to in the data center. On that same note, I'm going back to the Vincent.
All right, thank you, Rahul. Adding on to the call to action, it's very simple. Use it. The OCP diag is out to be used. It is going to structure and format the output so you don't have to reinvent an output or create some arbitrary output to your test. By doing so, you're doing a great service to every company and organization that already adopts the OCP diag spec, making your test portable and immediately transparently integrated into their test executives and their backend infra services. So you can start with the OCP diag quick start, and please bring that back to your teams, your labs, your office, and spread the word. Whenever you have a blank page started with a diag, just go to the OCP diag spec. You can contribute. Please go to the OCP diag core, where you will find all the details about the spec. It was designed by all hyperscalers and enterprise to include all the attributes relevant to consider when you're writing a test. And please provide feedback. We are active on GitHub, and we use GitHub discussions and GitHub issues if you encounter any issues. Final slide. As we say, it takes a village. This is obviously a community. A lot of interest is generated. We meet every other Wednesday, but details are on the wiki for the project, which you can find on the QR code on the previous slide when they're published. And we invite you to join the discussion and engage with us. So thank you very much, and hope you enjoy the happy hour and the rest of the conference.